Hello students, welcome to this session. In this session I am going to start with a new chapter called as stack. Till now whatever we have discussed, all those chapters will complete our first 2 units. So 2 units have been completed. So as we discussed the first 3 chapters, which are introduction to data structure, we have discussed what is preliminaries, and we have discussed string operations. Later we have discussed arrays, we have discussed searching, and we have discussed sorting. Now those 6 chapters will complete our first 2 units. Now third unit is our linked list. So I am not going to start linked list because until and unless you understand the topic of stack and queue, we cannot understand linked list. So first I am going to complete the topics of stack and queue, and later we'll go for the third unit, which is our linked list. So I'll start with the fourth unit, which will be having 2 chapters. One will be your stack and one will be queue. So we'll start with stack now. So what is stack? Stack is nothing but it is a linear data structure. Okay, so we have discussed different organization of data structure, organization of or classification of data structure. Under the classification of data structure, we have seen data structure is classified into 2 things. One is primitive and non-primitive. Under non-primitive, we'll come across linear and non-linear. So stack is a non-primitive. So non-primitive linear data structure where elements, whatever elements you are going to store, will be of homogeneous type. Okay, so it is going to store homogeneous data elements where elements are inserted and deleted from same end, or you can also consider it as single end. Okay, so this will represent a stack. So what is stack? Stack is nothing but non-primitive linear data structure where elements will be of homogeneous type and elements are inserted and deleted from a same end called as top. It is called as top, and it will be working in the form of last in first out. Okay, it will be working in the form of last in first out. If you want to give an introduction about this particular topic, you can also consider if you have any container which is closed in 3 sides. It is closed in 3 sides and it has only a single opening. Okay, it has been opened in a single place or in a rectangle. If you have all the 3 sides that has been closed, and if you have a single opening, so where you can add the element and you can delete the element. This type of structure we'll consider it as stack. Okay, in this kind of structure, say consider this is a container or this is a box which can store some books, which is used to store books. In that case, whenever I add the first book, that is B1, it will be stored at the bottom of the container. So that is the first element. This is the first element. Okay, and next, if I add book 2, it will be a second element. Like book 3, it will be a third element or third book, fourth book, and you have fifth book. Okay, I'll write B4 and B5. So once I consider this, if you observe here, we have added 5 books. First book, second book, third book, fourth as well as fifth book. Now, first element that was added was B1, B2 second, B3 third element, B4 and B5. Now, if I remove the element, when I try to remove the element, I cannot remove B1. If I want to take out B1 first, I need to remove B2 first. B5 first. After B5, I can take B4. After B4, I can go for B3, B2 and then B1. So in this case, if you observe the method or how the stack will be working, it will be working in the form of last in first out. So the element that is inserted at the last, which is fifth book, which will be coming out first. Okay, and this will be second, this will be third, this will be our fourth, and this will be our fifth book. So you can also consider something like this: whichever element you have inserted first in, last out. You can also write like this. Stack will be working in the form of last in first out or first in last out. Okay, so what is this top? So top is nothing but it will be representing this position or this pointer. Okay, this position what we are using, it is called as top, in the sense when there is no element in the structure or when there is no element in this container, it will be empty. So when this is empty, so that is nothing but we don't have any element here. When this is empty, we are going to consider top will be equal to -1. Why -1? I'll tell you. Because we will be using arrays. If I take an example of array, by using array, if I want to implement this type of representation, we know array we are going to start the index with 0. If the index is starting with 0, 0 will represent first element. Now I don't have any element here, so I will be representing it as -1. Okay. Now top is a pointer which will be pointing to the topmost element of the it will be pointing to the topmost element or topmost object of the stack. Okay, so topmost element of the stack will be represented by this pointer called as top. Now when top equals to -1, there will be no element in the stack or there will be no element in the structure. Now when I add the first element, first book B1, then top will be pointing to the first position, which is 0. If you consider array, since it will start from 0, I will give it as 0. Top will be assigned to 0. When I add book 2, second book, top will reach the next position, which is 1. And again, when I add book 3, it will reach the next position. So that is B3, book 3 and book 4 and 5th book. So when I add all the 5 books, top will be at the 5th position. So as I add the book into the stack, top will be incremented. That is, each and every time top will be incremented as I add the new books into the stack. Now the same thing, when I remove the book from the stack, what happens is stack will be, or top value will be reduced, or it will be decremented. So it will be decremented when it is when you delete. When you delete, we are going to decrement the value of top. When you insert or when you insert a new element, we are going to increment the value of top. At the initial position, top value will be what? -1. What it says? Top will be empty, or the stack will be empty. Now, when the top value is at the last position or topmost position, then we can say stack will be full. With an example, I'll explain you this once again. Now consider, the basic thing is stack is nothing but it is non-primitive linear data structure which is used to store the elements of homogeneous data types, and this uses the insertion and deletion of element will be done at the same end, and it will be working in the form of last in first out. These things you need to represent as the definition of stack. Okay, so hope this is clear, and this is the explanation regarding what is stack. Now we will see one more topic in the session called as the representation of stack. So what is representation is? Representation is going to explain how this logic can be implemented in your program. In your program, by using which method I can implement this type of structure. To represent that, we'll be using representation of stack. So representation will be done in two methods. One is static and another one is dynamic. Okay. So what is static representation of stack or dynamic representation of stack in the sense, static representation is nothing but when you have fixed size of memory. When you have fixed size of memory, in that case we'll be using static representation. When you have say the memory is not fixed, okay, when you are able to change the size of the memory, in that case we'll be using dynamic representation of stack. Okay, now how we are going to use this is, in the case, consider we have discussed something called as static memory allocation and dynamic memory allocation in your first semester. Okay, so static memory allocation is nothing but when you have what fixed size of memory. When you can fix the size, if you are using something like arrays, if I use if I define something like a of 10, in this case what is the meaning of this? I can store 10 elements of which data type? Integer data type. So this cannot be changed while I am executing. So while I am executing the program, I cannot increase the size or I cannot decrease the size. I can use maximum of how many elements? Only 10 elements. Okay, I can store only 10 elements. I cannot increase it. That is fixed. So that type of representation is static. Dynamic is whenever we are using the functions like malloc, calloc, realloc. So whenever you are using these kind of functions to allocate memory at runtime, so during execution, if you are able to allocate memory, then that type of representation is nothing but dynamic representation of stack. So simply to say, if I implement stack using arrays, then it will be static representation. If I implement stack using these functions, either malloc function, calloc function or realloc function, then it will be called as dynamic representation of stack. So dynamic representation we are going to see in linked list chapter. Okay, in linked list chapter we are going to explain in detail about what is dynamic representation. Now I am going to explain only about static representation. So static representation is for the implementation of static representation we will be using arrays. Okay, so static representation, since as I told you, we will be using what? We will be using arrays. So in the sense, if I want to store integer elements into the stack, I am going to give the definition or the data type as integer. Suppose the variable name is stack and I am going to store 3 elements into the stack. So what does that mean? That means we have created an array which can store 3 elements, and the variable or the name of the array is stack, which will be having 0, 1 and 2. Okay, this is our representation. Now I told you one more thing, whenever you are using stack, we will be using a variable called as top, which will be representing the topmost element in the array. So we are going to create one more variable called as top, which will be initially -1. Okay, so this will also be integer and we are going to assign it to -1 because it will be empty. Okay, now so we have 3 conditions while representing stack. One is when the stack will be full, so stack full, and stack empty, stack full condition, stack empty condition, and we have insertion, and we have also deletion, and we have other functions that we will discuss in stack operations. Now we will be explaining, I will be explaining only these things: how to check full condition, how to check stack empty, insertion as well as deletion. Now whenever we start, we can see top equals to -1. When top equals to -1, we can say stack is empty. First thing is how to check stack empty when stack will be empty. How to check that? So we will be using a condition called as if. If top is equals to -1, in that case we can say stack is empty. Okay. If top is not equal to -1, then we'll say stack is not empty. Okay. So now initial condition top is equals to -1, so this will be true. Okay. Hope this is true. How to check stack is empty? When top equals to -1, stack will be empty. Next condition, or next thing we need to check is how to check stack is full. That we'll see later. Before that, I'll tell you how to insert an element into stack. So how to insert an element into stack? How to insert an element into stack is, before any insertion or inserting an element into the stack, we need to check whether there is space in the stack or not. Okay. So whenever I want to insert any element into stack, what we are going to check? Whether there is a space in the stack or not, that we need to check. How to check that? We need to check stack full condition. How to check for stack full? Say for example, if I add 25 as the first element, so then it will go to the which position? 0 index. So I'll get 25 here, and we are going to have top at this position. So top will be at 0 position. Next, when I add one more element, which is 40. So if I add 40, top will be incremented and top will be at position 1. And again, if I insert one more element, which is say 60, so 60 is inserted and top will be at the second index. Okay. Now, if you observe, can I insert any more elements? No, it is not possible, because I can insert only 3 elements into the stack, because we have fixed the size as 3. So I can insert only 3 elements. Since I can insert only 3 elements, now if I want to insert one more element, it is not possible. So while checking insertion, or while doing inserting an element into array, we should also check for whether stack is full or not. Okay. How to check that? If you can observe here, if top equals to maximum -1. So what is maximum? Maximum will represent the maximum size of the stack. Okay. So maximum -1, then it will represent the stack is full. So if you observe, we have inserted all the 3 elements. Since we have inserted all the 3 elements, the position is 2. And maximum elements you can insert is what? 3. 3 minus 1 will be 2. So since both are true, then we'll say stack is full. So we'll say stack is full. Okay. Next, if this is not the case, in the else condition, what happens? In the else condition, as I told you, suppose if I don't have any element in the stack. If I don't have any element in the stack, it will be empty. When it is empty, what will be the value of top? It will be -1. So -1 equal to 2, it will be false. Okay. Since that will be false, we'll come to the else statement. In else statement, first what we are going to do, we are going to increment the top value. That is, I am going to write top plus plus. Top plus plus in this sense, it will come to this position, which is 0. That is -1 plus 1, it will become 0. We'll be pointing at stack of 0. So now I will write stack of top equal to element. So the first element which I want to insert was 25. It will be inserted into the stack. So this is a function which is used to do what? Insertion. Or this insertion function is called as push. So push function is nothing but whenever you want to add a new element into stack, that operation or that function is called as push function or insertion. Okay. So insertion of element will be following this algorithm. Next, we'll come across deletion. So when you consider deletion, so if I add other element which is 40 and also 60, now the stack will be full and top will be at the second index. Now if I want to delete an element, we need to check, before deleting an element, we need to check whether it is empty or not. In the sense, before deleting, if there is element, then only I can delete. If there is no element, I cannot delete the element from the stack. To check that, we need to check whether it is empty or not. I told you how to check the empty condition. So to check empty condition, we'll be using if top equals to -1, then we'll say stack is empty. Okay, and later we'll come across what are the things that we need to do. We need to do in the deletion is, what we need to do in deletion algorithm or deletion function is, so instead of these two steps, we'll be writing two more other steps. Like first I need to consider element equals to stack of top, and later we'll be decrementing the top value, so I'll be writing top minus minus. So this will be the function or steps for deleting an element from the stack. How to delete an element from the stack? First we are going to check whether it is empty or not. If it is not empty, I am going to consider element equals to stack of top, that is nothing but stack of top will be 60, element will be 60. Then I am going to decrement top value, well, that is nothing but top will be minus minus. So instead of second index, top will be decremented to first index. So once this is happening, so the element will be deleted from the stack. So this you need to represent in the form of a representation of stack, which is static representation of stack. So I'm going to explain all these things with the example of with an example and algorithms. So just understand, whenever you want to explain representation of stack, you need to explain all these conditions. First, what is the initial state of top will be -1, and you're going to create an array called as stack, which will be of 3 size. You can also increase if you want. So, and what are the conditions that we want to check? We want to check for full, stack empty, insertion and deletion. So rest of the topics and next topic we will see in the next video. Thank you.